There are places in our universe where reality doesn't just become dangerous. It becomes impossible. Where clocks slow down, light can never escape, and the laws of physics reach their breaking point. These places are so extreme that if you cross the wrong boundary, the rest of the universe might never see you move again. We call them black holes. But here's what most people don't know: there isn't just one type of black hole. There are several, each one is stranger than the last. And some of them shouldn't exist at all. In fact, one type may have been created before the first stars were even born. And another could reveal hidden dimensions beyond the universe we can see. For decades, scientists believed they understood black holes. Massive stars collapse, space-time tears open, a singularity forms. Simple. But the more we've studied the universe, the more we've realized something unsettling. Black holes come in sizes we never predicted. They behave in ways that violate our models, and recently astronomers discovered types of black holes that weren't supposed to be possible. If we're going to understand the universe, we need to understand every kind of black hole hiding in the cosmos. Because each one reveals a different secret about how reality actually works. Before we dive deeper into the different types of black holes, take a moment and imagine this. If humanity discovered a black hole hiding somewhere near our solar system tomorrow, would you want to know about it, or would you rather stay unaware? Let me know your answer in the comments. And if you love exploring the biggest mysteries of space, subscribe now, because the universe still has countless secrets waiting to be uncovered. The story begins over a century ago, when Albert Einstein published his theory of general relativity. His equations predicted something bizarre. If enough mass compressed into a small enough space, gravity would become so powerful that it would collapse in on itself, creating a region where our current laws of physics can no longer fully describe what happens. Einstein's own equations predicted black holes. But Einstein refused to believe nature would allow something so absurd to exist. He assumed mathematics was leading to an impossible conclusion. The universe had other plans. In 1964, a rocket-mounted X-ray detector scanned the constellation Cygnus and picked up something strange. A powerful source of radiation coming from nothing. No visible star, no nebulae. Just invisible violence. Imagine pointing a telescope into empty darkness and discovering an object tearing apart nearby matter so violently that it outshines entire star systems in X-rays. Scientists named it Cygnus X1. Years later, after exhaustive study, the scientific community reached a stunning conclusion. They had found the first confirmed black hole. But Cygnus X1 was just the beginning. Because as our telescopes improved, we didn't just find black holes. We found an entire zoo of them. Type 1 stellar black holes. The first category is called **stellar black holes**. These form when a massive star, at least 20 times the mass of our Sun, reaches the end of its life. For millions of years, the star burns hydrogen, fusing atoms in its core and releasing tremendous energy. That energy pushes outward, balancing the inward crush of gravity. But eventually, the fuel runs out. And when it does, there's nothing left to hold the star up. In less than a second, the core collapses. The outer layers explode in a supernova, one of the most violent events in the universe. But the core, it keeps collapsing. Electrons get crushed into protons, atoms cease to exist. What remains is something we still cannot fully understand. A region where matter has collapsed so completely that all the mass of a giant star may be compressed into a space smaller than a city. Stellar black holes typically range from about 5 to 100 times the mass of the Sun. To put that in perspective, a black hole only 20 times heavier than the Sun could have an event horizon roughly the size of a small town. 20 suns. One town. We've detected dozens of them in our galaxy alone. But they're not the strangest ones. If stellar black holes are the corpses of stars, the next type is something far more terrifying. Because it doesn't merely kill stars. It can control an entire galaxy. Type 2 supermassive black holes. At the center of nearly every galaxy in the universe, including our own Milky Way, lies something far more monstrous. Supermassive black hole asterisk. These aren't just big, they're incomprehensibly massive. Millions, sometimes billions times heavier than our sun. The one at the center of our galaxy, called Sagittarius A, weighs about 4 million solar masses. But that's small compared to others. In 2019, scientists captured the first ever image of a black hole's event horizon. It sits at the center of the galaxy M87, and it weighs 6.5 billion times more than the Sun. Its event horizon is so large that light itself takes nearly a full day to travel across it. Here's the mystery: we have no idea how supermassive black holes got so big. They exist in galaxies that are less than 1 billion years old, meaning they formed not long after the Big Bang. But according to our models, there wasn't enough time for them to grow that large through normal means. It's as if they were born massive. And no one knows how. Scientific explanation. And this is where the mystery becomes almost impossible. Because black holes are not cosmic vacuum cleaners. They are actually surprisingly bad at eating. When matter falls toward a black hole, it heats up and releases radiation. That radiation pushes other material away, slowing down the feeding process. This is called the Eddington limit asterisk. Think of it as a cosmic speed limit. No matter how hungry a black hole is, physics prevents it from feeding infinitely fast. Given this speed limit, supermassive black holes shouldn't have had enough time to reach their current size. Yet they did. Which means one of two things is true. Either our models are missing something fundamental, or the early universe was far stranger than we ever imagined. Which means either our understanding of black hole growth is incomplete, or something else is going on. Type 3 intermediate black holes. Astronomers kept finding small black holes. They kept finding gigantic black holes. But the middle-sized ones were missing. It was as if evolution had skipped an entire chapter. A middle child of the black hole family. They're called intermediate mass black holes and for a long time we couldn't find them. Theory said they should exist, black holes between 100 and 100,000 solar masses, but observations came up empty. Then the universe did something extraordinary. Instead of showing us black holes through light, it let us hear them through ripples in space-time itself. And some of those mergers produced black holes that were too big to be stellar, but too small to be supermassive. We'd found the missing link. Intermediate black holes might be the key to understanding how supermassive black holes form. Perhaps they're the seeds. Small black holes that merge over and over, growing into the giants we see today. But even this doesn't fully solve the mystery. Because there's still not enough time. Type 4 primordial black holes. Now we arrive at one of the strangest ideas in cosmology. Primordial black holes asterisk. These aren't formed from dying stars. They were born in the first moments after the Big Bang. In those early fractions of a second, the universe was unimaginably dense and chaotic. If the density fluctuated just right in certain spots, gravity could have caused tiny regions to collapse instantly, forming black holes. These could range in size from smaller than an atom to thousands of solar masses. Here's the wild part: primordial black holes might still be out there. Floating through space, invisible, ancient. Some scientists even think they could be the source of dark matter, the mysterious substance that makes up most of the universe's mass but has never been directly detected. If that's true, then black holes aren't just cosmic oddities. They might be the hidden skeleton of the entire universe. Think about that for a second. What if the universe is not mostly made of something invisible, but hidden black holes that have been drifting through space since the beginning of time? Do you think primordial black holes could actually be the missing dark matter? Yes or no? Write your theory in the comments. I want to know what you think. Pause for a second and picture this. Right now, while you're listening, an ancient black hole older than every galaxy we can see could be drifting silently through interstellar space. Completely invisible, completely undetectable, and completely indifferent to our existence. Black holes aren't just destroyers. They're storytellers. Each type holds clues about the universe's past, its structure, and possibly its fate. But there's one more type. The most controversial. Micro-black holes. According to some theories, especially those involving extra dimensions, tiny black holes could be created by high-energy particle collisions. Not in nature, but in laboratories. When the Large Hadron Collider was switched on, headlines around the world asked a terrifying question. Could humanity accidentally create a black hole that destroys the Earth? Scientists quickly dismissed this. Even if micro-black holes could form, they would evaporate almost instantly through a process called Hawking radiation, a quantum effect that causes black holes to lose mass over time. But here's what's fascinating. If we could create and study a micro-black hole, it would give us direct evidence of physics beyond the standard model. It would prove that extra dimensions exist. It would unite gravity with quantum mechanics. It would change everything. So we've journeyed through the black hole family. Stellar black holes born from dying stars. Supermassive black holes, cosmic giants that shouldn't exist yet. Intermediate black holes, the missing links. Primordial black holes, echoes of the Big Bang. And micro-black holes, windows into other dimensions. Each one expands our understanding of reality. Each one challenges what we thought we knew. But even after a century of study, black holes remain one of the deepest mysteries in science. We've photographed their shadows, detected their collisions, measured their spins. But we still don't fully understand how they form, what happens inside them, or what they're truly made of. The universe has given us black holes in every size and age. The question is, what else is out there that we haven't found yet? But this is only the beginning. The universe is filled with mysteries we haven't even discovered yet. So here's the question. If you could explore one thing in the universe, a black hole, another galaxy, or an alien world, what would you choose? Tell us in the comments. And if you enjoyed this journey to the edge of reality, subscribe and join us as we uncover more secrets hidden in the cosmos. If you want to keep exploring the biggest mysteries hidden in the cosmos, subscribe for more cinematic documentaries that take you to the edge of human knowledge.